So let's rewind a little bit here. Let's rewind what regulations apply, and then sort of the heart of what we're talking about today. How clean is clean, right? How do we know? Let's say we've gone through the process. We've decided we need to do an evaluation. We all understand you never want to take any sort of measurement unless you have some sort of a yardstick, some sort of a tool, some sort of way to measure your results, right? There's just no point. If I take a wipe test and I find out that there are 82 nanograms of mercury. All right, now what, right? That number in itself doesn't help me unless I have some way to interpret it, unless I have a ruler, unless I have some sort of scale. So that's where I'm going with this, how clean is clean. And I will tell you right now there are several different approaches, but some are worse than others. So we'll start with one. This is what I call the hazardous waste approach. How many of you guys know everything there is to know about hazardous waste? Come on, Ray. Okay, I'm being facetious. How many of you guys are familiar with hazardous waste? All right. I can't believe there's anybody whose hand is not in the air right now, right? We know hazardous waste, right? So there are a school of thought where you take hazardous waste values and apply them to surface contamination. That make sense to everybody? So you kind of dig out your regulatory limits, or maybe your RCRA limits, or maybe your RCRA listed wastes, and you apply them to wipe test results. What do you guys think about that? I see some heads shaking. I hear. I am happy to see heads shaking here. I think of this in terms of good news, bad news, right? The good news is we know these numbers, right? We deal with this stuff all the time. Right? Look it up in the same books. I don't need to have a new book. I don't need to find a new website. I'm all over it. And we pretty much understand the regulations, right? That's what we do for a living. That's like bread and butter, right? Hazardous waste stuff, I'm all over it. I got a checklist. I got clear regulations, right? Piece of cake from an enforcement standpoint or implementation. And this is an issue I'm going to come back to at the end of the game, when we're talking about facility decontamination, is it a safety issue, worker safety, worker health issue, or is it an environmental issue? I'm going to go with both technically, but if you had to do which was more than the other? It's really an occupational health or workplace safety or a people issue, right? But you guys, I'm being a generalist here, how many of you guys are environmental health regulators, right? So we kind of got the wrong team, right? I mean, I hope nobody takes that personally, but I mean, it's just the way it plays out. So environmental regulators, it just kind of stands to reason. If you're an environmental regulator, you kind of like using environmental regulations to get your job done, right? So how many of you guys heard that phrase, if all you have is a hammer, everything looks like a nail, right? And that's kind of my thought for this process. Now again, I'm happy to see heads shaking, right, when we talk about this hazardous waste approach, because I'm hoping we're all on the same page here and understanding that this is really, of all of the approaches that we're going to talk about today, this is really the only one that I would just say is wrong. There are others that are better, worse, strengths, weaknesses, pluses, minuses. You could at least make a case in some circumstances. This is almost the only one that is just plain old, not applicable. All right, so let's start at the beginning here. If I have a contaminated benchtop, is that hazardous waste? It's probably not waste. We can leave aside the question for the moment as to whether it is or is not hazardous, but it's not waste, right? I'm not saying it doesn't represent I'm just saying, so right off the bat, I don't want to be talking about hazardous waste regulations. And all of our haz waste standards are for haz waste determination, aren't they? Can't just go throwing them around in circumstances they don't fit. And I was a little bit crabby when I put that sentence in there. I've had some regulatory representatives that hopefully are not represented here, like want me to do things like sampling for methylene chloride, and then because there were detectable levels, let's not even talk about whether it was hazardous, just because it was non-zero, they started talking about applying F codes, right? Now again, I don't know how many of you guys get into hazardous waste determinations and things like that, but there are F codes and they are applicable in some circumstances, but if it's not a spent solvent, anyway, it's like, did I say don't get me started? Little pet peeve of mine is this sort of this misuse of F codes, but it really doesn't have anything to do with today's class. So the standards don't apply in the first place. Everybody clear where I'm going on that? Right? Apples and oranges, pick your favorite cliche. And then let's think a little bit about the data that I have. I do a wipe. Everybody familiar with wipe testing? Anybody done wipe testing? Anybody here not ever done a wipe test? A few people? We'll talk about it a little bit more later, but I think the concept is pretty straightforward, right? You have a area of a known dimension, a square foot, or typically we do 100 square centimeters, 4 inches on a side. We use a wipe, typically dry, although occasionally wetted with water, sometimes methanol. And we wipe in a very specific pattern. Typically we do S curves one way, S curves another way, and then we sort of spiral in from the outside, kind of fold it in between, stick in an envelope, send it off to the laboratory. Does that make sense to everybody? So what you get when you're done with a wipe test is a measurement of some number of typically micrograms of contaminant per wipe, right? It'll be a unit measurement of area. That's the key point here. So it's micrograms per wipe, and in my lab report, if I said I wiped 100 square centimeters, then I'm getting micrograms per 100 square centimeters. It could be per square foot. There are, and we'll talk about these, some of the standards that we were talking about before are given to us in units of square meters. So in my mind, it always makes me smile. Who is it that's out there thinking that we're wiping a square meter? You know what I mean? But anyway, the point being that it is a measurement of mass per unit area. Typically, it's 100 square centimeters. Sometimes it's per square foot. All right? Just for the sake of simplicity, my TTLC units are what? What units are TTLC results given to me in? Milligrams per kilogram. Can I get, let's forget micrograms. Let's say I get my wipe results in milligrams per wipe. Can I go from milligrams per wipe to milligram per kilogram? You can't get there from here, right? You just can't be done. I don't mean like I don't want to do the work. I mean it can't be done. And I've had people tell people that should know better, tell me with a straight face that I divide it by 20 or multiply it by 10 or all sorts of craziness out there.
You can make an assumption about what depth you're going to include or something like that, and then come up with a...
We're going to come back to that. We're going to come back to that issue. We're going to come back to that issue. In general, right, you can't take a hazardous waste number and apply it to evaluating whether there's at least a hypothetical where you can use it to determine if that table itself would be hazardous waste if it were waste. And I'll kind of walk through that. It's sort of just a mathematical or an arithmetical exercise. But you understand where I'm going here is that I can't go from micrograms or milligrams per wipe to milligrams per kilogram. Mass per unit area cannot convert to mass per unit volume or unit mass. Does that make sense? We just can't. Not like we don't want to. And the weight percent of the contaminant on the wipe, does that tell me anything? Let's say my wipe is 30% lead. Does that mean my bench is 30% lead? No, it just means I had a lot of lead when I did that wipe. It may indicate that there's a lot of contamination, but it doesn't help me, right? I can't compare it to occupational exposure limits. How many of you guys have done air sampling before, right? Familiar with PELs, TLVs, where we get airborne contaminations, milligrams per volume of air. Again, I can't go from a wipe directly to one of those units. It just does not compute. So all of the approaches that are available to us that we'll talk about today I hope I have convinced you that this one is the only one that is just wrong. Am I on the same page? Awesome. So now let's talk about some other approaches that are out there in the world. Let's see what we think about those. What's that look like? What is all those Sudafeds? What do you think we're doing with all that Sudafed? Either somebody's got a really bad cold, or somebody's cooking a little meth, right? And we were talking earlier about the meth standard here. Methamphetamine Contaminated Property Cleanup Act of 2005. Show of hands again, several people in the room have some firsthand experience with this. I know you and I, we probably did. We do the first one in San Diego? Right? I mean, it was like in 2005, right? And so, been doing these for a while. I don't do a ton of them. And the ones I do tend to be small, little mom and pop kind of deals. So this law, as some of you may know, established a very specific process to be followed when a property is determined to be a meth lab. Not just when people use meth, but when the property has been determined by law enforcement to have been a laboratory where they manufactured. And it establishes a fairly rigorous set of procedures for a preliminary site assessment. Where is the contamination? And then a work plan to remove the contamination, and then a specific set of procedures to follow up to make sure that the contamination is all gone, right? What's a legal specific requirement? The lien is attached to the deed of the property, and it cannot be released until the local enforcement agency signs off. You are required by this law to get a CIH to do this. It's the only law that I know of that you really have to have a CIH, so I'm kind of happy about that, but to do the assessment and to prepare the work plan, not necessarily to do the work, and then to do the clearance. So usually it's a combination of a CIH overseeing a hazmat contractor. And that's what the law requires. It says this is what you got to do. And it established a reoccupancy level of 0.1 micrograms per 100 square centimeters. All right, again, written into the law. Now, I will tell you, just because this isn't the kind of thing that people just know off the top of their heads, but that's really, really low, right? That's a very, very low number. No, it's now higher, but we'll come back to that. We'll come back to that. That's the original number. You guys are stealing my thunder here. You're just... We'll come back to that. Hold that thought. So here's that number, 0.1 micrograms. Now, sir.
Was that for a specific
Methamphetamine. There are other provisions in the law for mercury and lead, which we're just ignoring for right now. The mercury number is also super low, but just in the interest of telling the simple story, we're going to focus on methamphetamine. And the rationale was that, is there naturally occurring methamphetamine? Right? So is there a background? Like mold. How many of you guys do mold sampling, right? We do comparative analysis because we got this huge background we have to deal with. Is there background methamphetamine? Should be. Same way. Yeah. Anybody here from Merced? Can we make fun of Merced a little bit? Right. So what they said was, you know what? There shouldn't be any background. There shouldn't be any methamphetamine. So I'm going to say my clearance standard is going to be 0. But they had their thinking caps on. So they said, you know what? I can't get 0. They were at least that smart. And they said, I'm going to set my clearance level at the analytical limit of detection. If there's any, based on the methods that were in place at the time, and it's specified in the standard and all that kind of stuff. So that's where this number, 0.1 micrograms per 100 square centimeters, comes, because that's the lowest level that we could accurately quantitate. All right? So what do you guys think about that? It is hard to get to. Is that important? Say that one again louder for me. Is it worth cleaning it up to that level? That, to me, is the heart of the matter. Is it worth cleaning it up to that level? What are you guys saying? What do we need to know to answer that question? Is it worth cleaning it? Right? What's the health hazard? Now, let's back up a little bit. There is a significant body of research that has been done showing that large-scale methamphetamine contaminates essentially everything. There's a guy named John Martini in the Denver, what's the Denver hospital that does a lot of respiratory stuff? And what doesn't matter. He's done a lot of research. He's worked with DEA, and they've done simulated methamphetamine cooks. They've done studies of prisoners, people that have been busted for meth doing labs, and they've done wipe samples on the people, on their clothing, on the kids. There's always kids in these houses. So I'm putting it out that there is a demonstrated hazard for methamphetamine contamination. I'm just making it up here, all right? However, this point of, is it necessary to get to that level? Notice on there, does it say where the contamination is? When you do lead, anybody here do any lead work, lead assessments? Where do you look for lead? Do you look in the ceiling? No, right? Does this limit it? Does this tell me? It says nowhere. So I will tell you in practical experience what happens with that number. People that cook methamphetamine, what else do you think they do with methamphetamine? They use it, right? And it turns out, and again, this is not based on scientific study, this is based on my personal observation, that when you smoke methamphetamine in a house, you contaminate surfaces at levels at or above 0.1. So you come in and you find out that the knucklehead brother-in-law was, like you said, cooking the pseudoephedrine out of the Sudafed in the bathtub in the downstairs bathroom. But you follow that plume of smoke in the downstairs bedrooms, and oh, they were smoking meth in the kitchen while mom was out. So now you find it in the kitchen in the living room, right? So now I have to come in, and I'm bound by law, we all are, right, to comply with that level. And we go through that process, and I forget where we were mentioning before, you have to follow a very specific wipe test protocol using methanol. And again, I don't understand the science of it, but it's like that methanol just sucks that methamphetamine right through the paint. Because I've tried encapsulating it, I've tried cleaning it, I've tried every combination and permutation thereof. And I have not found an approach to encapsulation that is reliably effective. Right? So I can't just go in and know that if I paint it twice with Kills or some high solid sealer or clean it with TSP or whatever, where I'm going to be done. And understand that there are costs associated with all this. Question?
I'm just saying, wow, that's really something.
And I've heard people say, oh, I just do this. And then I say, okay, because I don't pretend to know everything. And then I go do whatever they said. And then I have the same, you know. And then sometimes something will work. I'm like, great, I found the solution. But then the next time it won't work. So where I'm going with this is that if you come to me and say you have one of these projects, it has taken me years to come around to this point, but by and large, I'm telling you, I'm just going to rip whatever rooms are affected down to the studs. I'm just taking sheetrock off. Because it seems drastic, it seems extreme, but that is the only approach I know will get you to done. Right? Otherwise, we're going through this cycle of cleaning and painting and sampling and cleaning and painting and sampling, and that has costs associated with it. Now, I'm not saying always, but by and large. And I have colleagues that were there ahead of me, and they're like, screw it, I'm not messing around with it. We're just going to do that. And I fought. But like I said, I've kind of come around to that conclusion. Just because it's so hard, or it was so hard, we're gonna follow up on this. So here's the thing, though. I got a little bit of methamphetamine contamination in the downstairs bathroom. I got a little more in there. Is that worth ripping the house apart? And again, understand a couple of things here. First, what kind of houses, what kind of parts of town is it that you think these things are happening in? Right? This isn't the best part of town. Are these, and then again, my experience tends to be the knucklehead brother-in-law.
Not always.
Fair enough.
We had a situation, it was
Care to name any names?
Living in their outside cottage in a nice neighborhood, and then they got caught because one of the buyers came and the son got in a fight on the lawn with the guy, and the neighbors were like, "Oh my gosh, there's a fight!" So they called the police, and then that's when they discovered that the meth lab was in the cottage.
Right. So, I mean, of course it's going to, but by and large, and what happens is it's generally not the property owner who is the responsible party, right? It's some person who owns this house. It might be a rental property, or like I said, a lot of times it's daughter's boyfriend or son-in-law or whatever. So you get this person, these are not high net worth individuals as most of the time, is where I'm going with this. And you're coming in and you're telling them that we essentially have to gut their house. Now, again, my question is, and it's just what we were talking about, is it worth it? Is there a health hazard present there of sufficient magnitude to require that kind of action? Yeah.
So the standard was probably not based on any kind of health-based, probably something about how.
No methamphetamine should be there. Any is too much. Therefore, we're going to clean it to zero. But thank you for saying, say again what you just said. It's not based on? It's not based on any health-based. David.
A lot of times politics is based on somebody's perceived idea of fairness. Is it fair to make the next person live with this methamphetamine when all the other people live or don't have it? It's not fair. You gotta fix it. It's not fair.
Well, in the Africa, I suspect they don't know at what level it's going to be a hazard for a child that's going to touch a wall, maybe thermally exposed. So it's like, hey, in the absence of whatever 20 years of studies that cost millions of dollars, it's nothing to do. They're going to say,
So you're saying it was hard to find test subjects to determine?
To volunteer? Yeah. Wipe and lick. I got student workers that do that all day long.
how would you understand the joke?
That's exactly where I'm going with this. What we would like to come out with at the end of any sort of a process is some sort of an understanding of the dose. We would like our criteria to be risk-based. This is really hazard-based, correct? This is methamphetamine is bad, Methamphetamine bad, kind of the Frankenstein approach, where we would like to be risk-based. There's no attempt at dose reconstruction there. And I went to some of those public meetings, and I sat, and there was even, I forget was it EHA or DTR or whoever it was, brought their tame IH in, and he stood up and basically said, no methamphetamine should be there, so we should go to zero, and then we should take the drywall off, and then we should sample the studs, and then maybe we should like sand off the surface level of the studs and taste the wood underneath. And it was astounding to me that there was not even a consideration of any sort of a toxicological approach. But that's just the way it was. I'm throwing it out there. That's an approach, right? There's just a number. And essentially, the number is zero. And while, again, I use this example facetiously, it's the way I think about things. How much arsenic do you want in your drinking water? I don't want any, right? But we don't get zero. And we need to. And also, what politician wants to be the one that's, the supporter of the meth house owners? You know what I mean? What politician is the one that's going to be the champion of the people that own meth houses and tries to relax the standards, right? So there's not going to be a whole lot of political momentum to back this up. But this is a specific example that I'm going to come back to. So this is not the end of the story. But you understand the reason. We set a very stringent standard in place. It sounds good, right? No methamphetamine. Great, that's got to be healthier. But there are significant consequences to those decisions. And when we, on my end or on the regulator end, go through this process, we can't always just say, get rid of it all, because there are significant consequences. And in my mind, that needs to be balanced by the benefits. There needs to be a sufficient risk to justify that expenditure of resources. Does that make sense to everybody? So in this case, I would say this is not a very sophisticated approach. So I'll give you a little bit different one. Can you guys make out what that thing is there? Does anybody know? It's kind of a blurry blob. It's a wave solder machine. I can't even see what it is from back here. That's a wave solder machine. Now that's used in electronics manufacture. And what they do is they have a pool of molten solder that is vibrated such that it has a standing wave, a ripple on the surface. And the circuit board is moved over and through it such that it applies the lead just to the very tips of the little protruding wire bits that stick through the circuit board. And that way you can solder a whole bunch of them all at one time, and it's a production tool. Everybody with me? Now, today, how much lead is in solder in most electrical components? Essentially zero. Unless you are making a product that has some sort of overwhelming requirement for leaded solder, like a mil-spec part or something along those lines, essentially no commercial manufacturer uses leaded solder, right? You guys agree? I mean, I just don't see leaded solder other than a very, very few specialized locations. However, back in the day, this was a recognized source of potential both personal exposure and area contamination, right? Because you got essentially a big old bucket of hot lead. Now, I think you guys all probably understand that the temperatures at which we heat lead to solder don't necessarily volatilize enough to cause significant area contamination, but when you sit there and put a lot of energy into it and vibrate it and things like that, you'd get plumes. The machines would always have ventilation, but it wasn't always super effective. So this is a recognized source of contamination. So that's why I put it up there as an example, all right? So here in California, we have our friends at Cal OSHA that have kindly given us a lead standard. And this is essentially identical to federal standards. And it says that all surfaces shall be maintained as free as practical of accumulations of lead, all right? And we have similar requirements in the OSHA standards for some of the other metals that have substance-specific standards, all right? What does that mean? What's practicable? As clean as it's possible to get it?
No, you're right, huh?
At reasonable cost? Well, that's a good one, right? Because do you think that the regulatory perspective is going to be the same as the business owner's perspective on reasonable cost? Of course it is. We're all on the same team. We're all in this together. So you can see that there's some inherent uncertainty there. Practically, what this means is that what you do is you sort of sample a clean area and a dirty area after it's been clean, and you should not find removable contamination, right? But there's a lot of uncertainty there in it, isn't it? And I'm going to get right back to the same thing that we talked about before. Is this a risk-based approach? There's no risk assessment here. I can detect it. I should not detect lead. Now, the circumstances of this are a little bit different because it's an OSHA standard, correct? And OSHA applies where? In a workplace. So we have a different set of standards, a different set of assumptions. And frankly, if I'm eating my sandwich, I want to eat my sandwich at lunchtime at a table that does not have lead contamination on it. Right? So it's substance specific. It's for certain metals and things like that. So it's a little bit different, but in a way it's fairly similar to the no detectable contamination that we were talking about a few minutes ago, right? So at least it's an approach. I know we're not an OSHA crowd, but generally this is intended to protect workers, and you generally do some sort of a comparative analysis to evaluate that. So what do we think in terms of facilities decon? Would that be appropriate? My plating shop closure or my shooting range example I gave you, would this approach be suitable? That's going to be a daycare. So we want to be even more protective, you're thinking, right? Okay. Well, okay, we'll come back to that. Right. Just what we just said, what's the dose, and am I being overly protective, or am I not being protective enough? Right? We don't know because this is not a risk-based approach, is it? Right? This is just presence or absence. Presence above a certain level is better than limit of detection, but this is just presence or absence. This is not a risk-based approach, but this is an approach that's out there in the world, and every employer that uses lead or some of these other metals has to comply with the standard. That's, that's an OSHA standard. You have no choice in the matter. In fact, we've done.
It allows for some flexibility with the regulators.
I'm sorry?
It allows for some flexibility for the regulatory part of it.
It does. It does. As the term flexibility always makes me just a teeny bit nervous because I like flexibility when it's my kind of flexibility. I guess where I'm going with that, I don't mean to be facetious, but again, I get to work with all sorts of different regulators, and there's something to be said for a known, solid outcome rather than a question mark.
Well, I was just saying in comparison to maybe the net.
Absolutely. Absolutely. And it does, and it allows for the accommodation of some level of contamination in dirty areas of a facility. If we're in some sort of a manufacturing facility that uses arsenic or lead or something, it allows for recognition that this is the dirty area where that work takes place. This is the clean lunchroom. We got to have procedures to get from one to the other. But so I mean, it is workable in its appropriate context, right? And I'm going to go with what I call the regulatory approach. We're going to go with Department of Energy has a standard for beryllium. Those are fuel rods, right? Where that's beryllium on the outside. Awesome metal. Beryllium has all sorts of really interesting physical characteristics and properties. Super strong, super light, transparent to X-rays. However, it's also one of the few chemicals, materials, substances out there in the world that we see that kind of scares me. You know what I mean? And I kind of work with hazardous materials for a living, but there's this issue of chronic beryllium disease. It's essentially a sensitization reaction that affects some people, but we don't know who, at really, really, really low doses. So beryllium's kind of scary. Right? We don't see it too much in general industry, fortunately, although in days past, it was very common to use beryllium copper alloys for bearing surfaces and things of that nature, machine shops. So anymore, though, you don't see beryllium outside of certain very specific DOD or DOE facilities. So nasty, nasty stuff. Because of that, we actually have a DOE regulation, chronic beryllium disease prevention, that sets both a housekeeping standard and what they call a release level. So they recognize that we can allow different levels of contamination for workers, educated, trained workers, subject to appropriate HAZCOM and things of that nature, but workers to use. But we want to set a lower level if we're going to send it off-site, right? So I'm going to buy a chemical fume hood from Oak Ridge National Lab, right? That's going to be subject to this free release level, right, of a lower standard than the housekeeping level that they may keep it at. Yeah, why would I want to buy from Oak Ridge? But so that's out there. That's just a number, right? That's a number. Does that apply to anything other than beryllium? Nope. Does that apply anywhere outside of DOE? Nope. But at least I got something, right? So that's out there. This number isn't exactly risk-based, but it kind of is, because you know what they did? Where do you think that number came from? Like many things in the DOE complex, somebody back in the day made it up. And it kind of sort of seemed to work.
But isn't that kind of the way that worker standards have been generated as well?
Absolutely. I'll tell you a real quick story. How many of you guys, I used to do a lot of lab safety. I used to really be involved in laboratory safety. Anybody here do a lot of lab safety work? So what's the face velocity of a chemical fume hood? Face velocity of a chemical fume hood. What's the number? Sounds like 100 feet per minute, right? 100 feet per minute is the face velocity. That's just kind of a number that's out there. Cal OSHA's got a couple of funky things where they say it's supposed to go up to 125, which is a different story. We got this number, and everybody that does lab safety says 100 feet per minute, 100 feet per minute, 100 feet per minute. You look at every book on chemical fume hoods and lab safety, it's 100. Where does 100 feet per minute come from? Well, say again?
It was probably easily achievable.
When they were doing the Manhattan Project, it just so happened that the fume hood in one of the buildings where they were working with plutonium happened to make about 100 feet per minute, and it seemed like it worked, right? It seemed like it was effective. It said, all right, good enough, we're good to go, and then that's been captured. There's no studies validating 100 feet per minute. It's just a number. And similar, yes, sir?
Don't people do smoke studies all the time and capture studies and stuff?
To show that it is effective. But there's never been like a start from scratch, like what's the it's basically showing that it does there. And you're right, though. I mean, I'm being a little facetious. If you follow the ASHRAE 110 containment test and all that kind of good stuff, absolutely. But just the origin of that number was just empirical. Seemed like it worked okay. And that's where these beryllium numbers come from. Seems like it works okay. They did a study of workers at, I always want to say Oak Ridge, Rocky Flats, and it seemed like they weren't having too many beryllium-related problems with the Rocky Flat workers, so they said, all right, we're good to go.
That was pre the big lawsuit.
I think that was probably sort of in association with all of that kind of stuff, but don't ask me for the, I don't know when the standard was promulgated. But essentially, while not being explicitly risk-based or not based on a specific exposure assessment model or anything like that, at least there's a component of risk-based to this approach. Does that make sense? At least we don't know what the exposures were, but they were working with it. They weren't getting sick. So it's not based on limit of detection. It's based on some observations that were made. And we're going to come back to this beryllium number in a minute because it's used in another circumstance too. So I talked about that. Come on, there we go. The other place we see a similar kind of number are the HUD numbers. Housing and Urban Development has established allowable levels for lead dust in residences. Anybody familiar with this? Any lead inspectors or assessors? Anybody here got a Niton in the trunk of their car and goes out and does a bunch of lead work? This is well established. This is applicable to residential, but it is based on blood lead levels of exposed children. Now, I understand that there is some emerging body of knowledge that this, what they were considered to be allowable levels of blood lead is now considered to be high. There's some changing evaluation of the underlying assumptions, but this is a similar principle, if that makes sense to you. They said, well, we've maintained the levels according to these standards. There's actually a few more. It's a little more than that. And we're not seeing blood lead levels in children above what were at least considered at the time to be allowable levels. Therefore, these must be okay. Does that make sense? Kind of risk-based, a little bit. At least that's the way I think about it. All right. Uh-oh. There we go. Scared me there. So we got a couple more. Then we're going to take a break. And then I'm going to give you guys some scenarios, and maybe we'll try and work through those in a group a little bit and see where that takes us. So bear with me for just a couple more examples of a different approach. I'm going to call this the OEL, meaning occupational exposure limit. Anybody here an industrial hygienist in IH? All right. Well, remember what I said earlier, that joke that I made making fun of environmental regulators and saying that if all you have is a hammer, everything looks like a nail when we were talking about environmental regulations? You guys remember that? Well, I'm gonna turn that one on myself, or at least on my profession, because I'm an industrial hygienist by background. What do industrial hygienists do? Well, okay, that's all well and good, but practically speaking, you get an industrial hygienist to do some air samples, right? And so we're all about inhalation hazards. Now, I have several well-respected colleagues that say, hey, as a profession, maybe we're not focused enough on these other routes of exposures. But kind of the cliche, the IH tunnel vision is all about those inhalation hazards, right? So this is the IH approach here, where that's my hammer, or my nail, I'm not sure which. But do you guys know what this is, what kind of facility this is a picture of with this yellow light and these funny chemical fume hoods? Fab facilities, right? Semiconductor fab facilities. I heard a lot of different things, but I'm sure that's what you're all saying, right? Fab facilities. Now, the thing about fab facilities is they use a ton of different kind of chemicals. They use some crazy hazardous corrosive substances, gallons and gallons and gallons of hydrofluoric acid and piranha etch, and they'll use some caustics, and they'll use photoresists that have reproductive toxins in them. They use a whole bunch of different substances. A wide variety is where I'm going with this. So this is a little bit different than some industries that may use a lot of chemicals but only one kind, all right? So there's a school of thought that really comes from the semiconductor health and safety world. There's a school of thought that says, look, we've got all of these types of chemicals. We need a good approach to evaluating surface contamination. Now, do we have recognized limits for surface contamination? Can I look them up in a book? Not really. Do we have recognized airborne limits that I can look up in a book? Yes, I do. I got lots of them. Maybe not every PEL or TLV for every chemical I'd like, but I have a lot, right? And buy that book every year. They make me spend whatever it is, $40 or whatever, that stupid little paperback. So I can look at, so I got inhalation values. So wouldn't it be nice if I could take my inhalation values and somehow use them to derive a surface contamination level, right? So like I said, semiconductor industry, they have sort of taken that. So here's an example of this approach at work. If you look up your arsenic TLV, it's 0.01 milligrams per cubic meter. All right? Everybody with me? It's an airborne level saying that at that concentration is an 8-hour time-weighted exposure. Nearly all healthy workers are going to be safe. Right? So how much air do I breathe every day? It can be calculated. In fact, I don't even need to calculate it, because if anybody's ever done any site assessment or risk assessment work, I get a big book of all of those kind of values. And if I look it up in my great big book of everything, it tells me that it's a reasonable risk assessment assumption to say that normal workers will breathe 20 cubic meters per day. Now, I believe that that's a 24-hour day, not an 8-hour work day, but let's not split hairs. All right? So you guys remember back to your high school math, chemistry, science classes, unit conversions and crossing units off, I can take 0.01 milligrams per cubic meter times 20 cubic meters per day, and that gives me 0.2 milligrams per day is essentially the amount of arsenic that I could be exposed to if I were exposed at the TLV. Does that make sense to everybody? You know, I'm going to freak everybody out with heavy mathematics here, but it's pretty straightforward, right? That's essentially an allowable amount of arsenic. Now, toxicologists and the folks at the ACGIH would be raising their hand telling me how wrong I am, but at least in concept, you understand where I'm going with this, right? So, if I'm allowed as a normal healthy worker sort of 0.2 milligrams per day of dose, right? We can kind of wave our magic wand and turn that into a surface level by pretty much arbitrarily saying, well, let me back up. I mentioned before that frequently we use 100 square centimeters as the area of our wipe test. Do you guys have any thoughts as to why we do wipe tests in 100 square centimeters? It does make the math pretty easy, but I don't think that's where it came from. It's about the size of a hand, right? So you're right. I mean, it kind of works out a whole bunch of different ways, but at least the story is it's about the size of a hand, 100 square centimeters, roughly. So what you do is say, all right, if I'm allowed 0.2 milligrams of arsenic over the course of the whole day, I'm going to allow that level of contamination in about a hand size area. So that if I touched it and all of that transferred from there into here, I would be at my level, which is a pretty unrealistic, it's a pretty extreme exposure scenario, so it's intended to be a little bit conservative, right? And there's a bunch of assumptions in there. But I'm just saying this is an approach that's out there. Now, what do you guys think about that approach? Does that make sense? Does that seem like a sensible approach? So pluses, it's conservative, right? If that's my limit, I'm unlikely to be overexposed. Say again?
You're basically on inhalation, but then you're modeling a dermal.
Thank you. Is that a valid assumption?
It's conservative. Maybe.
I don't know. So cons, I'm unsure about the toxicology.
If you're in that facility, aren't you wearing gloves?
Oh, yeah. Absolutely.
Contact. You take off your gloves before you, I don't know, lick your hand or whatever.
Right. Yeah, no, absolutely. So yeah, I mean, you would certainly have some level of protection. Just saying in terms of setting a standard, kind of worst case, unrealistically.
Sweaty glove, and then you just have to rest your hand down there.
And then you eat your sandwich for lunch, making sure to smear the bread all over your... But you get where I'm saying. You guys understand the methodology here, the mechanism? So cons, this is pretty sketchy from a toxicology standpoint, right? Any toxicologists here, right? If you were, you'd be running for the door right now, right? This is not a toxicologically sophisticated approach. However, I can look up OELs for a lot of chemicals, can't I? Right? And I can do that math pretty simply. So at least it has the benefits of being somewhat easy to come up with, right? So pluses and minuses, all right? But from a exposure assessment standpoint, I'm just not 100% sure there's a lot of technical basis for making the leap to standards that are based on how much of this I inhale to how much I get on my hands, right? So I think there's significant question marks.
But we're talking about a cleanup, right?
This would typically be used in the semiconductor industry for allowable levels as the facility is working. So the question would be, is this something suitable that we might want to apply in a cleanup? Right? Again, has the benefit that I can crank them out pretty easy for a wide variety of substances. But again, I don't know if it's super, I don't know if that's the best approach. And even in California, we have allegedly the surface contamination limit for methylene bischloroaniline that has been established. It's one of the only surface contamination standards, that a numerical limit that I'm aware of, was, I shouldn't say allegedly, that sounds so accusatory, reportedly was based on this model where they used a 10 cubic meter daily inhalation rate to better represent a workday compared to the 20 cubic meters, right?
Are there any published studies on this toxicological approach?
No, that I'm aware of. It'd be a tough study to do. You know what I mean? I mean, you'd have to train rats to wipe their paws or something. I don't know. I would be, but I'm not aware of any. But I'm also not a toxicologist.
You could do medical surveillance. There was a contaminant where you could have biomarkers and you could study the workers.
Absolutely.
And you could see based on their activities.
But think how many I mean, I'm not saying you couldn't be doing it, but I mean, it would be tough if you wanted it to be robust. And I'm just not aware. I mean, it would be fantastic if there were. But there are some studies, or at least there are some more sophisticated approaches. So bear with me for a little longer, and I'll get to the ones that are a little more sophisticated. All right? I think that one's a little bit out of order. Cadmium, where's my photo? There's my photo. All messed up. Cadmium telluride. How many of you guys heard of Solyndra? I think there's a talk. Somebody's given a talk about cleanup. Oh, that's your talk. There we go. There's a little plug for you. Well, there are other non-Solyndra solar facility cleanups, and they use this cadmium telluride process, which had some very significant manufacturing benefits. And essentially, they use vacuum deposition of this cadmium telluride process. So they make these monstrous, great big, gigantic, huge stainless steel tubes, a couple of foot square by 50 or 60 foot long by like 1.5 inch steel or stainless steel plate. And they pull a vacuum on them, and then they introduce the cadmium telluride compound in there, and it deposits out on the glass. And they do all sorts of clever things to it to turn them into solar cells, right? But what makes the cadmium telluride only deposit on the glass and not everywhere else on the inside of the oven? Nothing. That's exactly right. So it tends to be fairly messy. So my question for you is, how much cadmium can I have? How can I evaluate cadmium contamination? Any thoughts? Just getting to be a little too late in the afternoon? Well, I'm with you. So I will cut to the chase and say our friends at Brookhaven National Lab came up to an approach. And this is one you mentioned earlier about recognized national standards, and I was a little bit facetious, but there are a couple of approaches that are sort of widely recognized, and this is one of them, this BNL approach, Brookhaven National Lab. All right? Now, I wish I could talk to someone. I will admit I have not personally had a discussion with people that established this because I have some questions, but let me walk you through what they do. The Brookhaven Lab, BNL, and you can go online and you can find their wipe sampling procedures, and again, it's fairly widely used, the BNL values. And they have, remember, where else did we see housekeeping and release values? What other contaminant? Beryllium, right? We'll come back to that, all right? This is widely used. There's my cadmium telluride. So here's what they do. Here's what this BNL approach is. What they do, whoops, did you get all that? Yes, the presentation, I uploaded it last night. I'm going to give you guys a couple of handouts. And pretty much all the documents I refer to are also available, maybe not on this website, but they're available on the internet, including this Brookhaven National Lab guideline. So here's how it goes. The levels for a particular metal are set using a ratio approach. All right, so here's what they do. They say, I was warned not to get too close to the speaker. We'll see how it goes. They say they take the DOE release level for beryllium divided by the beryllium PEL should be equivalent to the metal release level, the metal of concern, cadmium in this case, divided by that particular exposure limit. And you just got to make sure you keep all your units straight. Anybody else scratching their head? I really don't understand the technical justification, all right? But the way it works is that essentially you're taking if the beryllium release level is 0.2 micrograms, beryllium PEL is 2 micrograms, 0.2 is 0.1, and again, the technical part of my brain just freaks out a little bit because those units don't cancel out, so I don't know what we do about that, but we're just going to forget about that, and I end up with the conversion factor of 0.1 times the particular metal exposure limit, except that now I'm in 100 micrograms per 100 square centimeters. Right? Poof, right? Magic wand. So the arsenic TLV is 10 micrograms per cubic meter. The beryllium, using this method, 0.1 then, the Brookhaven National Lab arsenic free release level would be 1 microgram per 100 square centimeters. All right? Now, like I said, I don't quite know where this, how they came up with this, but that's a widely recognized number that you will see industrial hygienists using. Remember I said earlier that whole bit about if all you got's a hammer, it looks like a nail? IHs, we're going to take those airborne inhalation levels and use them everywhere we can, right? And that's kind of what this feels like to me. Similarly, Cadmium TOV is 10 also, so we get the same. So my question, is this a risk-based value? I don't think so. I don't think we're quite there yet. All right, so I got a couple more, but why don't we take another 10-minute break or so, stretch our legs. It's getting to be that part of the afternoon.